Hey guys, welcome to Hybrid Automation Technologies. Here we are going to see some basic components of this PLC programming. Who are new to this tutorial or who want to learn the GX developer or Mitsubishi PLC programming, they can go through this video, and if it is helpful for you, kindly like and subscribe to my channel, and if anybody needs this kind of videos, kindly share these links to them. So we'll go with the GX developer. Here we go. So we'll create a new project here. FX CPU I'm going to select, but 3G this model is not able to simulate, so I'm going to select FX1 and C, and the programming type I'm going to select is a ladder program. So and click OK. So some of the components, means here what all the things are there, I'm going to explain each of them. So first we'll start with the F5, that is if shortcut key for this is F5, that is a normally open contact. Here for the input x0 to x7 and x11 x102 x17 x20 to x27, like this in octal we have to 0 to 7, in the sense 8 we are going to count. And for input address we have to take it as a x0, but in real time if you are going to use the PLC, then directly you can take it as x0, but while doing the simulation and all, you can trigger x0 actually. But if you have connected the real PLC to this computer system, and from here program, if you want to trigger x0, it is not possible because it is directly linked to the PLC input. From there only you can trigger the x0. So right now I'm going to simulate this, so I will use directly x0. In simulation it is possible. So next one output I'm going to take. So step by step I'm going to tell all the things. So F5 is the shortcut key, and shift F5 is the parallel contact. If I want to create a shift F5, I will add. And one more thing, that Y0 is the output coil. Here I'm going to take. Here you can see one parallel contact is created. If I do undo and if I double click over there, here you can see this minus thing shows that normally open contact in series, normally close contact in series, normally open contact parallelly, plus indicates the parallel contacts, and coil, and these square brackets indicates the timer and counter. If we want to program, then we can to take these things. And in series, if we want to take the pulse, positive edge trigger and falling trigger, and parallel contacts if you want to take, then these things we can add. And this is the instruction. Right now I'm going to skip this one right now for this instruction. So other things I'll select a parallel contact, I will select, and Y0 is the output contact, so I will add it here. And next thing is normally close contact. For this we can press F6, directly we'll get this selected over here. You can see here it is already been selected. So this I'm going to take a next input address, that is x1. And if you want to have one parallel contact to this one, so for that shift F6. Okay, shift F6, you can, means it is already selected, it has been selected, and it is this enter symbol palette will open here. Just you have to add the address and press enter or click OK. Okay, it will add the contact over there. And next part is that output coil, F7 you can add, and Y0 I will take. Okay, this I have added here. Next this is a square bracket, means application instruction. For this we can take here for example, when this coil is energized, I'm going to trigger one timer over there. Okay, so I'll take one timer over here. Before that, I will take one normally open contact in series and put the address same as output coil of Y0, and now I will take it as F8. I will press or I will click the button over there. See, it is already selected, and T0 is the first timer address of this program. Okay, and space we have to put, and K50. Okay, K50 I am going to add and click OK. Just a second. Okay, this instruction is for actually the add multiple options and instruction, where we are going to add arithmetic and logical operations. Okay, so this coil we have to take coil here, we have to take T0 space K50 I will add and press enter. This is the timer address T0 we have taken, and now if I press X1, it will turn off this output coil, and I will add one more thing, that I am pressing F6, and T0 address I am going to add here. Okay, now we'll convert this one. I need to press F4 to convert the program, or else here you can go and press F4, or you can click over here. Okay, after this thing, if you want to simulate this thing, just you have to click on this button, and so it starts creating one virtual PLC. One panel will come over there, it will start that PLC FX1 and C. Here you can see this model is been selected. It's about to start now. Now virtually it is writing the PLC program in that PLC, virtual PLC. This is the main program it has been writing over there. Once if it starts, see there, run, we can put it in stop mode if it will not run, and run it is now. I will minimize this window. Now just we have to click over here, okay, no, just press shift and enter to trigger the input. Okay, once if we trigger, this is closed, this contact is closed and output coil is energized, and this parallel contact with the same address. So when this is energized, this normally open contact, parallel contact, is going to be closed, and here we can see it is parallelly connected, and this goes to the Y0. So when I release this, here you can see the timer, even I'm holding this. So just a second, once if stop, see, I have released this 4 5. Okay, just a second, we'll increase the timing over here. Okay, it is in monitor mode now. Wait a second. See here, this is in read mode, this is a write mode, and monitor mode, and monitor write mode. While monitoring the program, we can write the program, which is not acceptable actually, but write mode we have to click to do the changes in program. Write mode I will select and press K5. I will add K100. Okay, so this timer, just I'm going to tell, like 100 second is equal to 10 second. Okay, 100 second is equal to 10 second. So I will click OK, and again we have to convert this program by pressing F, or just we can go through this convert and click this button, click this option actually. Okay, and now we'll start our simulator. Once it starts, it will take a time to write the program, updated program in that virtual PLC. 100% main program writing. 1 2 3 start. Yeah, so it is now started now. Okay, here you can check this. This is the preset value. No, this is the preset value, that is K stands for constant and 100 is the time delay which we have given, and this is a count value. Okay, when I trigger this X0 and release again, you can see this timer, it started. I will release it now. 6 7 8 9 10. Okay, after 10 seconds this T0 address is going to be energized. This coil is going to be energized, and this T0 address, this is normally close contact, so this will get open, so this will turns off the Y0. So this is a simple program to explain how written over there. Okay, this instruction set I'm going to tell in next session. So it has got some advantage like add, multiple, move commands, everything we can do using this application instruction. Okay, let's move to the next options. Okay, we end the logic test. So again we move to write mode. Okay, write mode. So step by step I will explain everything. So consider there is no line over here. So if we want to add the line over here, okay, just press F9. Horizontal line if you want to add over there, F9. Okay, F9. Okay, just click OK. No need to add anything over there, it will be connected. Okay, so if we want to add one more parallel contact to this shift F9, we can add over here. From top to bottom it will draw the line. So here F5, this is Y1 I'm going to take. So again one horizontal line. Okay, no, sorry, vertical line. So now this is connected. If we want to delete the lines, here delete. See, we can delete this, we can delete the horizontal rungs. Okay, directly we can press delete here. Okay, this is all about the these parts. Okay, some of the things are disabled because some PLCs will support these things and not. Okay, so we will see which all the things are enabled. Okay, this is the shift F7. We can, this is for a rising edge trigger and this is a falling edge trigger, and this is a parallel rising edge trigger and parallel falling edge trigger. What is rising edge trigger and falling edge trigger? Okay, I'll just let you know what all those things step by step. So I'll remove this program completely. So again here I will take one parallel contact with the X0. Okay, and raising its trigger, that is shift F7. Okay, F7. So here I will click OK directly. This no need to put any address for that, it is in series, it will come in series. Okay, so now just to explain I'm going to take one coil over there with the M0. M0 stands for the memory bits or the flags, internal flags we can use, many more flags we can use, and the parallel contact of M0 I'm going to take over here. again one output coil that is called y0, and this y0 I'm going to have parallel contact here, and this one is x1. Okay, so as soon I trigger this x0, this m0 will produce one pulse, means this rung will be high for 1 microsecond. Okay, high for microsecond, and that pulse, that coil is energized, m0 coil is energized for a microsecond. That closes this m0 contact, and it will turn this rung to true. That energizes this y0 coil, which makes this normally open contact to close, and it will latch. This is a simple latch circuit. I'm going to take in multiple examples, sorry, not exams. Okay, uh, this is an example, and when I trigger this x1, this rung will go to false condition because it disconnects the signal from left to right. And for falling edge trigger, we'll see this example, like I can copy this code, no issue. Okay, here x0, but here I will take one falling edge trigger. Simply both are same, but here I'm going to change the address like m1. This also I will take it as m1, and output address also I will change to y1. Same here. Now I will convert this program by pressing F4. Just a second, what is the issue? So actually issue was that this raising edge trigger and falling edge trigger are the input, means this we have to trigger, this we are triggering. So instead of taking these them separately and putting the address for them, directly we can take it as a x0. Okay, here I will take it as a x0 simply, and this I will take it as a x0 falling edge trigger. Okay, this I will remove. Okay, this is done. Now let's convert this program and start simulation. Simply means rising edge trigger and falling edge trigger, that particularly things we have to, because I'm using lots of PLC programs like Allen Bradley, Mitsubishi, Siemens, Delta, GE, Fanuc, everything. So in different PLC there are little bit different things are there. So in Micrologics 500 and all, directly we can take one raising edge trigger block over there, and we have to put the address for that. Okay, at the end we have to put one coil, and that coil we are going to that coil address we are going to take it in a program for using. So here for those raising edge triggers and falling edge trigger blocks, one particular input must be needed. But in Mitsubishi, this FX3G, sorry, GX developer software, we have to take it like this only. Okay, just we'll start simulation. Here, as soon as I trigger x0, okay, it will remain on, x0 will remain on continuously, but m0 will be energized for microsecond, and this will latch the y0. As soon as trigger x0, this will be turned off. But when I will release x0, at that time this rung is going to be true for microsecond, and that will energize the m1 coil, and that latches the y1. And as soon as I trigger x0, sorry, x1, so both side I have taken same address, in the sense it will not work, I think. So I have to take different address for this. So a little bit some logics we have to change, so accordingly I will change the things. So now I have to put it in a run mode, and I will take it as a x2, convert it and start simulation. It will take a little bit time. Okay, it is running now. The mistakes which I am going to do in while creating this video, I am going to keep them. I'm not going to edit them, I'm not going to correct them, because the same mistake you can avoid while doing the program. If because after long time I am touching this GX developer software, so I got confused. So I was taking separately that falling edge trigger and rising edge trigger. So now we'll check this. Here I will trigger x0. See, only this is energized, okay, but still it is on. Okay, now here this is a falling edge trigger. Here I am going to trigger release. Okay, so when I release this, because it will not be visible actually, you can see, I will trigger this x1, release, trigger, release. Okay, so this I'm going to show you. I triggered this, it will be triggered for a second, but it is still on, it is still on. Okay, it is still on, but when I release this trigger once again, means I'm going to release this. Okay, in actual PLC, when we push the push button, okay, it will connect the circuit. Okay, when I release it, it will disconnect the circuit. Okay, I'm talking about NO. Okay, if we are taking that as a NO, then it will work like that. So when I release this, at that time this Y1 is triggered, turned on. So guys, these are the some basic points I explained in this, and some other points I will tell you. Like I will go to edit mode again. Okay, these are the points you, as I told, edit mode, write mode, monitor. While monitoring we can edit. Okay, ladder instruction, list view. Okay, this ladder instruction is there. List view, if you want to check LDF x0 out. Okay, LDF in the sense falling, out is the coil, LD is a normally open contact, M1 OR. Okay, we are ORing this LD with Y0 output. Again, these are the things. Okay, so now we'll check the ladder program. Okay, this is the program now. So some points like I will edit in edit mode. Okay, now these things you can see: comment, statement and note. Okay, comment, statement and note. If you click here, directly you are getting symbol entry, means you can address the, you can put the input address and all. But if you want to mention something like for this run what action is going to happen and all, so how to write that, you can add it in a comment. Like now I am going to click over here. Okay, I will add here like this is trigger, this is trigger run. Okay, this is called comment. Here also flag bit. Okay, this is the comment. Now statement in the sense, if I click here, this is for triggers. Okay, here it will show the instructions. Okay, apart from that, now this is the note. Here if I click here note, memory bit flag. Okay, click OK. So this is the statement. Okay, like this you can add comments, statement and note. Okay, and if you have selected these points, then if you click, if you want to change this thing, if you want to change this x0, x1 and all, it will not work out for that, because this here you can see this must be used for the coil side. Okay, at the right side of the rung. This must be used for in between the rung. Okay, this must be used for the left side of the rung, that is statement. Like here it will show the statement. Okay, if I select this statement and click over here and type, it will take here only. Okay, one more thing you can see, the m0 address here same I have taken, so automatically it will take here also, everywhere it will take automatically. So now convert it. Okay, this is all about simple concepts which we want to learn. And in edit mode, if we go, if I want to take one parallel branch over here, okay, free draw line. Free draw line is for this thing. Directly I can click here, I can draw the line. Like this I can draw the line. If I want to remove the lines, click this. Okay, if you want to draw like this, we can draw the line. Okay, this is final things. I think, I hope this video is helpful for you for editing the program ladder logic, and some concept like a raising edge trigger and coil concepts and shortcut keys I told you. If this video is helpful for you, kindly like and share, and don't forget to subscribe, and don't forget to push the bell icon, so that whenever I am going to upload next videos, hope those will be helpful for you. It will give you the alerts, notification as soon I upload the videos, so you will not miss those videos. That's why don't forget to press the bell icon too. Thank you guys, thank you for watching my video, and share, like and subscribe to my channel. Thank you.